So hello, my name's Karli Prather. I'm an intern working at the Pixel Lab over at the University of Pennsylvania. Over the course of the summer, I've been helping develop a web application, um, and I'm just going to tell you all a little bit about it. So the overall purpose of this project really was to create an interactive and sort of customizable representation of the ovary, mainly for use in science communication and to resolve some inconsistencies as far as ovary nomenclature is concerned. My individual task over the summer has been to sort of give the actual user a point of reference in the form of a pelvis model. Um, this presentation should introduce you to the tech stack that we've been using, which is the different softwares used for development during this project, as well as some basic ovary anatomy, the orientation of it in the pelvis, and project origins. And finally, I'll be looking at the actual process of this pelvis's addition. So as for my personal background and motivation, I don't really have much of a medical background. I'm not pre-med, but I do have a pretty strong computer science background and secondary interests in biology, female reproductive health, and reproductive health in general, and science communication. And really, that's the root of why I wanted to work with Pixel. Whenever I read the internship description, it really described a field that I care about, especially with my background coming from a rural location where education on reproductive health wasn't super important. Now, as for the actual inspiration for the project itself, last year there was an ovary nomenclature workshop over at the Shriver Institute that introduced this new nomenclature, and really it was a large discussion between experts from several different fields that were trying to create more consistency as far as nomenclature relative to the ovary. Over here on the right, you can actually see what the project looked like at the start of the summer before I started working on it. That should give you a good reference as to this next slide, which shows this final actual model that I've included and gives you sort of an idea as to the real reason we gave for including this pelvis model. Beforehand, you had really no idea where this ovary sits inside the patient, inside whoever you're looking at as an example. But let's see. So moving on to the actual meat of the project that I worked on. This is the tech stack. It's basically just the makeup of the different softwares that we used over the course of the project. Here, you just mainly have to think about CMake, VTK, and ParaView. CMake is basically the software that we use to compile this ovary generator so that we can put it together in multiple different forms, both to use in a regular runtime window as well as in the web application. VTK was the major library that enabled us to actually generate these different models, put them together, write them to a file, so on and so forth. And ParaView really is just the big debugging tool that we used throughout this project to look at the 3D models without actually having to reopen the web application. Moving on to my actual process, I started out really with a inconspicuously large task. You wouldn't have imagined this taking that long. But it actually ended up being a whole 5-step process where we had to read in this GLB file, which is a pretty standard 3D model file as far as the greater world of 3D modeling is concerned. However, with VTK, it is far from standard, and there is not really that much support other than reading in a GLB file. So from this initial GLB file with the raw data, we went over into, we converted it into a multi-block data set, which basically is just a data set made up of different blocks, which contain the objects, edges, points, surfaces, so on and so forth. From there, we convert that into a surface data set, which is just taking the actual surface data from that multi-block and basically just getting rid of all the rest of it. And from that surface data set, we filter out everything except the poly data. So we get a polygonal data set from that. And from there, we then convert this into the actual 3D model object, to the polydata object that we can actually use within our web application and program. And from there, it's a pretty simple process of just scaling up the pelvis to what you would normally expect. In our case, since we're measuring things in millimeters, it's scaled up to about 290 millimeters or 29 centimeters, which is around the average width for a pelvis. And then after scaling, since it's not been transformed or really put in a relative position to the ovary, we rotate that pelvis and translate it over so that it makes sense as to where that ovary actually is relative to the pelvis. And from there, we can integrate that into our web application, which can be used in several different ways to represent different morphologies of the ovary, and really represent these new nomenclature subdivisions of that ovary. And really that's the whole point of this technology, of this web application, right? Is to give a good visualization as to what those new subregions really look like to someone who's maybe just learning them or needs a good point of reference as to where these different regions are located on the ovary.
2 minutes remaining.
I'd just like to go ahead and thank you all. First of all, the HuBMAP program, this has been a really amazing program for me. I've really enjoyed the project that I worked on. Everyone at the University of Pennsylvania, especially my PIs and Jalay Howe, for all the help that you've been to me. And I really appreciate all of you coming here today and listening to my presentation.